we have dealt with a parabola, which is when we took a cone, we sliced it off, and we got one little section of it, right? So depending upon how we slice it, as long as we go through the top of our cone, so it just keeps going and going and going, we're not having an end point, we will always have a parabola. The angle at which we go determines, so the angle, which when we were talking about linear equations refers to the slope, right, determines the skinniness and the width of our parabola that we get, right? Okay, so moving forward, as we have our cone, the next easiest way to cut our cone is just to go straight across the middle, right? When we cut it across the middle, we end up with a circle, okay? So when we have a circle, when we're looking at conic sections, so we're all dealing with quadratics, everything, the highest exponent that we're working with is a squared term, correct? So when we have one squared term, that's always a parabola. Okay, so if you were to have a whole list of different equations, remember, if we have one squared term, we have only a parabola. Remember that when we were talking about it, when we have y equals x, back to linear equations, that's for every x there's a y value, right? And it's equal each time. So every time we're moving up, so we're keeping everything in a straight line. When we square it, one of our terms is going in little sections, right? But the other term is going at a curve. So x is going at 1, but then y would be 1. If x is 2, now y is 4. When x is 3, y is 9, right? So when we square a term, it causes movement along the graph in a curve, all right? So we are curving with parabolas, as we were looking at. We were curving one of them, right? The x's were staying, and we're curving as we're going along the y. Okay. Now, what if we have two squared terms? Okay. So now, instead of having that, we have an x squared and a y squared term. Okay. So now we know that we're curving along the y. Now what do we have to do? We also have to curve along our x. Okay? So we're curving our y's, and then we're also curving our x's. So when you have two squared terms, you now have curvature in two separate directions. Okay? What that does is that gives you roundish shapes. Okay? Or it gives you curves that are going out. Okay. So as we walk through, we're going to be talking about circles, ellipses, and hyperbolas. Let's start with what it really looks like with a circle. Just kind of talk over some vocabulary here. Okay. If I have a circle, for those of you who've already taken geometry, you'll know some. Okay. If I have a circle, I have a center point. Okay, we have a center point of a circle, and then we have the distance across. What is that called? Radius. It's your radius. Okay? So your radius, if I were to have a pen and a string and stick it in, and I went all the way around, my radius would be the same all the way around, correct? Okay, now, so let's look at maybe what a circle looks like if I were to stick it on a graph. What does this top part of the circle look like that we've just studied?
Parabola.
A parabola. And the bottom part?
Parabola.
A parabola. Okay, so we have curvature. Basically, we have two parabolas that we're sticking together. Okay? And we're ending up with a circle. So we're going to be working with both an x squared and a y squared. Okay? So anytime that you have two squared terms, we're dealing with something that's complete. okay, when they're added together. Now, when I squish my circle, this now becomes an ellipse, okay? So on an ellipse, our initial formula is going to look just like it is with a circle. We're still going to have two squared terms. We're just going to be dealing with different coefficients because on a circle, the curvature is exactly the same all the way around, correct? So the curvature of x has to match the curvature of y all the way around. Now we're looking at this, and if I were talking about, if I looked at it as a parabola, if I looked at it up and down, would my parabola curvature be the same? Yes. Yeah. This one is just negative and this one's positive, but the number would be the same, right? Now, what if I divided it left or right and I looked at these two parabolas? Would these two have the same curvature?
Yeah.
Yes, but would the curvature left and right match the curvature up and down?
No.
No. So this parabola would not have the same curvature if I was looking at it that direction, correct? So when we are looking at an ellipse, our curvature numbers, which are our coefficients, are going to be different, okay? So as we're walking through, same thing, the numbers are telling us something different about it, okay? If I were to take my circle, and instead of adding these two parabolas that maybe have our vertex that direction, okay, so if I have this parabola, parabola 1, added to parabola 2, they're connecting here, right? So if I take, and they have the same vertexes, and I don't add them, and instead I turn these, so I'm turning this out, this direction, turning these two sections, and we're turning them out, I now have a hyperbola, okay? Same curvature, so it's going to be the same. We're still dealing with an x and a y. We're still dealing with the same curvatures, except they're going, instead of being added together, they're going to be subtracted. Okay? So as we work through all of these series, the circles, ellipses, and hyperbolas, I want you to see that they're not three completely separate things. It's the same form. We're dealing with the same curvatures. It's just how we're putting them together. All right? That's a big picture of how they all connect. All right. Now I'm going to try to follow my notes. Okay. Okay, so we have looked at parabolas have one squared term. Okay, so for circles, when we curve in both directions, we've got two squared terms. So that's going to give us a circle, okay? Now, because of geometry, when we talked about our circle, and we have our radius here. For a circle, our curvature is dependent upon our radius, okay? So our circle formula is going to be x squared plus y squared equals our radius squared, okay? So this is our overall thing. So the constant here, this r, now if I had 25, I would want to write it in a squared term. So what is 25 written in a squared term?
5 squared.
5 squared, okay? So this would, the 5 would then be our radius, okay? So we're talking about curvature along the x and the y line that's going to line up with some number, and that number gives us the radius, where it's at, okay? So, when we are talking about curvature, just like with parabolas, okay, when we had y equals x squared, and our curvature was 1, right, that was just our standard parabola, correct? Now, when we started adding numbers, like we added 2, it made our parabola get?
Steeper.
Yeah,
Or
steeper,
skinnier.
so skinnier together. If I added 1/2, it made our parabola
Wider.
wider, okay. If I added a number onto the end, what did it do to our parabola on our graph?
Up and down, chase
It shifts it up and down. Okay. Now, on our parabola, when we took our parabola and we broke it out, and it's just y equals x squared plus a b here, and there was nothing attached to the y and the x, what did that automatically tell us about our parabola? Where is it located on our graph?
Right, at the origin.
At the origin, right? It was located in the origin. So then, remember how we worked out, so we had y minus y1, or y minus k, equals our curvature, so they had big A, x minus h squared, and then plus whatever number that we had, right? What did this h and k tell us?
That was like the points or something.
It was
the vertex.
the vertex, and it would tell us if our vertex was moved off of the origin, correct? Okay, so all of these letters, this format here is gonna stay exactly the same as we work into circles and ellipses and hyperbolas, okay? So, in our circle, we know that we are moving along the curve in both directions. For a circle, the rule about circles is that your curvature, which are those coefficient numbers, remember? So the coefficient number of a parabola told us the curvature, how steep or how wide it was going to be. For a circle, what do you think the coefficients need to, is there something special about the coefficients? Can you just think all the way around? Do you think they're going to be the same or are they going to be different?
The same.
They're going to be the same because no matter how I slice this circle, if I have a parabola, if I look at the parabolas up and down, they're going to have the same curvature. If I look at the parabolas left and right, they're going to have the same curvature. So for a circle, the coefficients of your x squared and your y squared must be exactly the same. Okay? If they are not the same, it is not a circle because that means you are curving at one rate in one direction and another rate in a different direction. Okay? So that's going to be something we're going to be coming up to. All right. So here is our basic formula for a circle. We've got x squared plus y squared equals r squared. Okay, and that means that this circle will start in the origin because I have nothing added to x, nothing added to y. So when we add nothing, we are moving it nowhere, so we're starting at our starting point, right in the middle, okay? So, just like I said, just like a parabola, when the x was all alone, it started in the origin. When a circle is all alone and there's no other x or y values, it's going to start in the origin, okay? So if we were going to take our circle equation, just like our parabola equation, and we were going to add h and k back in, we would have x minus h squared plus y minus k squared equals my radius squared, okay? This is the long version of your circle formula. All right, so for this equation, this takes if you have a circle that's not at the origin, this takes everything into account. So same thing, we have just added our h and our k, our movement, either direction in there. All right, so let's practically look through what that looks like for a circle. I'm going to rewrite this up here. So the goal with our parabolas was that we were able to look at equation and say, without really working out, say where it was located, what direction it went, if it was moved, you know, like that. So same with our equations for our circle. So if we have, this other one, x minus 1 squared plus y minus 2 squared equals 5 squared. Okay, the first thing that we're going to look at, so if you want to write down steps and think through for circles, first thing that we're going to look at is, what is this a graph of? Is there one squared term or two squared terms? There's two squared terms. So that gives us three different options, right? It can't be a parabola, okay? The second question is, what are the coefficients? So what are the coefficients of my x and my y?
Wait.
What's the coefficient right here?
1.
This A and this B.
1. Right?
They're both 1, so they are the same. Our coefficients are the same. When the coefficients are the same, we automatically know that we are working with a circle. So we have a circle. Okay. When we have a circle, this constant tells us something.
How big it is?
The constant gives us the radius of our circle. Okay? If the constant is not in a squared form, so say we had 25, we would need to find the square root to put it in a squared form. Okay? So the constant is your radius squared unless it's already in squared form. Okay? So let's look through this one and see if we can graph it. I know it's a circle. My A and my B are exactly the same. Okay. Where is it located? Where would be the center point? It is not at the origin because there are numbers added. So x has been moved and y has been moved. And just as a reminder, x always goes first, y always goes second.
Positive 1, positive 2.
Okay, positive 1, positive 2, right? It's the opposite sign because, remember when we talked about this, if I were to set x minus 1 equal to 0, I would need to move that 1 to the other side. When I change signs, I change sides, I change the sign, okay? So I'm going to start at 1, 2 for this circle, okay? And what is my radius? 5. The radius is 5.
So then just count 5 out.
So you would go 5, 1, 2, 3, 4, 5. 5 in every direction. And you would draw your circle around. Okay? Bad graph. Now, if I know that my radius is 5, how would I write our what they will call vertexes or edges of it? What could be some points that are along the line of this circle?
6, 2.
Okay. Perfect. 6, 2 would work. So if I keep my y the same, I would add 5, right? Because my radius is 5. What would be the one on the other side?
Negative 4, 2.
Negative 4, 2. So I'm subtracting 5 now from my center. So I'm starting at my center, and I would add 5 for my radius here. I would subtract 5 to go backwards, right? I have to be 5 in all of the things. Okay, so now if we were going vertically, and I'm going to leave my x value the same, so now I leave my x value.
1, 7.
So now what does my y change to?
7.
7 and
Negative 3.
negative 3. So now I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so So now I know that I have points along the graph, okay? So circles are pretty simple, 2 squared, and then you tell where you move off. Now, okay, so it says if we have, what do we do if we don't start with our equation in our vertex form?
Make it that.
We need to put it in our vertex form, correct?
Yeah.
Okay, so if we start out with x squared minus 2x plus y squared minus 4y equals 20, okay? We start with this and they say graph this equation. Ah! Okay, looks overwhelming, right?
Yes.
Okay, first thing that we do is group. Okay, remember when we grouped and we factored things out and stuff? Okay, so just like with parabolas where we had to complete the square, now what are we going to have to do? Complete the square twice.
Yay.
Okay, so we're going to take the first one, x squared minus 2x, and how do we complete the square on this one? What needs to go there?
Half squared.
Half of 2.
1.
So 1 squared. So I add 1. Cardinal rule of math. I added 1 to this side.
Add it to the other side.
I've got to add it to the other side. Okay? Now I have my y portion. Y squared minus 4y. What goes here?
4. Positive. Right?
Positive 4. Correct. Half of 4 is 2. 2 squared is 4. I added 4 here.
Gotta add to the other side.
Add 4 to the other side. Now I want to rewrite my completed square as a square. X, the square root of x, square root of 1, and I use the middle sign, correct?
Mm-hmm.
Right. Same thing on this side, square root of y, square root of 4. I use the middle sign. Now 20 plus 1 plus 4. 25. Excellent.
What?
Okay, so now I'm back to my circle. My vertex is 1, 2. My radius is the square root of 25, so my radius 5 squared is 5. Now we have gone back to where we were at here. Okay, so when we start with an equation, we complete the square root twice to get it into this vertex form. All right? Now, a little bit of geometry is going to be involved here for the next thing. When we have a circle and this this is because if you do go on to higher math or need to take like a ACT or something, they will ask you this, okay? They want you to graph a circle and they give you 2 points. They give you a center and a point on the circle, okay?
Is that?
So thinking about our circle equation here, okay? All we really need for a circle equation is our center, correct?
Yeah.
And the radius. We don't really need much more information, correct? It's a pretty simple, straightforward equation for a circle. So if they give us the center and they say graph a circle whose center is at 1, 2, we can already fill in one whole side of the equation, correct? So I would already know, well, okay, and let's do center at 1, 1. I would already know okay, so if I have my center, they tell me my center is at 1, 1. All right, and a point on the graph is at, I don't want to do that one. We'll figure it out. Let me see if I put one in here.
1, -3.
I thought about having you guys bring your. Sorry, I'm not that good off of my. At 4, 5. Okay. So my center's at 1, 1, and a point on the graph is at 4, 5.
That's a 1, 2 though.
There we go. Right? So now I have these 2 points, but I need to come up with the equation. I need to know what that distance is, correct?
3, 4.
Because this is the radius, correct? Now, in geometry, we're gonna look at this. On a coordinate plane, we can go straight across and straight up and down, and we can make ourselves a right triangle. Okay? Because of the Pythagorean theorem, which says that it's actually A's, A, B, and C. A squared plus B squared equals C squared, right? So we have A squared plus B squared equals C squared.
So,
I'm looking for C, right? How would I solve for C? We know from our PERMDAS, right, that I needed, if I have a square on one side, I need to take the square root, so I can change this as C is equal to the square root of A and B, right? Didn't change anything different. How do I find out A and B? Okay, so if I have 1, 1 here, and I have 4, 5 here,
3, 4.
what does that mean this point is? It has the same y, correct?
So 1, 5.
Has the same y, and it has the same x as this one. So my point where I'm transitioning for my right triangle is at 4, 1. Okay? So that means that A is from 1 to 4. So how far is A? This is on a graph, so we can actually count it, right?
4. Wait, 3.
3. So A here is 3.
3, 4. 3, 4.
Okay? What is B?
4 away though.
4.
Is 4. Okay.
4.
So
That's
we
five.
knew that because we graphed it and we actually counted over, right? We figured out our point. To go from 1 to 4, I need to go 3 spaces. To go from 1 to 5, I need to go 4 spaces. Another way that we can write this is if I'm looking at my 2 points, so this is point 1 and point 2, all right, is I can take, so my A value is the x of 1 of my point 2, right? Minus the x of my point 1, right? Because whenever I moved down, wasn't that the same? 4 minus 1 gave me 3? And these have the same x? You still with me? Okay. To find my y, I did the y minus the y of my original, my point, minus the y of my center, right? Because if I moved it over, then that's the difference I'm finding. Okay, so if I do x minus x, 4 minus 1, do I get 3?
Yeah.
3, perfect. If I do 5 minus 1, do I get 4? Yes. Okay. So we've worked through showing that if we have 2 different points, when we take the difference of their values, it's really giving us the sides of these triangles, of this triangle that we've made. You following me? Questions? Yes. No. Okay.
Right there with you.
Okay. So we now know our A, we now know our B, we can use our Pythagorean theorem, where our c is the square root of a and b. So now I have the square root of 9 plus 16, which is the square root of 25. So c is, so technically we're supposed to be doing plus or minus, right? When we take the square root.
No, this though.
But does a negative distance make any difference? Does it make sense? It'd be a black hole inside. We don't want a negative distance, okay? So now I have 5 equals c. So now I know that my distance between these 2 points is 5. My distance is also my radius. So now I go straight back over and I plug that in. Okay?
So you did, okay.
So
So you did all that just
to finish up the equation. So if they say write the equation of a circle with a center at 1, 1 and a point at 4, 5.
The equation's done, right? You don't have to solve it. You just,
No,
Okay.
this is what you've done.
Well, you did.
Or
solve
if they say graph it, or most of the time it'll say write the equation. Then here's our equation. Now, this formula right here has a special name. It is called the distance formula. Okay?
Can you use it in a sentence?
What?
It's like.
It's
like,
just,
you know,
they'll
graph
say,
the distance from A to B or whatever.
Mhm.
That okay.
so it's just called the distance formula.
Okay. I've heard that before, but I didn't know if it was like its own.
Okay, so the distance formula, and it might be on one of the handouts I handed
It
you.
is. It's
laughing
on the
at my
circle
good
one.
question.
Yeah, on the circle one. So at the top of the circle one, it says the distance formula. So it's all those numbers. What I want you to see is that it is simply your Pythagorean theorem. A squared plus B squared equals C squared. If you forget the distance formula and you don't have that memorized, okay,
Go to Google.
we can always find it out. Okay, this is the point of going back and seeing what are our base blocks that we know. I know that a squared plus b squared equals c squared. I know that if I have 2 points, I can make a right triangle that will satisfy this. Okay? Unfortunately, I don't know A, I don't know B, but I have 2 points. Because I have those 2 points, I can figure out A. So A is simply x2 minus x1. B is simply our y2 minus y1. And that equals our c squared. Okay? I want to find c. So I'm going to take the square root of c squared, square root of this side. Square root of c squared is simply c. Okay? This is our distance, or your radius. You can write those different things on there. So I've got the square root of the difference between my x's plus the difference between my y's. Okay? That's where that comes from. Okay? The other formula on there is the midpoint formula. So let's look at that and say, I have these 2 points, 1, 1 and 4, 5. I want to find the middle. How would I find the middle there? Okay, let's practically think through it. The middle is going to be the middle of our x's, right? We need to find the middle of our x's and go up. And the middle of our y's and go across, and that would give us our midpoint, correct?
Yeah, 3, 3, right?
Does that make sense?
Yeah.
To find the middle between 2, I need to find the middle of my x's and the middle of my y's, and where those meet is the middle of my points. Okay? So, let's think about it. How would I find the middle? What was the length of my side in the first place? It was my top x minus my bottom x, right? And now I want to find the middle of it. So how do we find the middle? We do a half. Right? So if I want to go here, I'm going to do 1 plus 4 is 5 divided by 2. Remember, that's how we find, we take an average of numbers, right? And that's going to give us the middle. To find the middle between these two, I'm going to add both of my y numbers. and divide them by 2. Right? So 5 plus 1 is 6, divided by 2 is 3. So now I go to 1, 2, 3, because if my distance here, we decided if our distance here is 4, what's halfway? 2. I would need to go up 2, right? And come down 2. So 1 plus 2 is 3. Is that what I ended up with? With 5 plus 1 divided by 2 equals 3. We got the same number, right?
Yes.
So same thing here. If I go between 1 and 4, I've got 3. So halfway is going to give me 1 1/2. I need to go 1 1/2, right? So 1 plus 1 1/2
5.
is 2 1/2.
Yeah.
So I have 4 plus 1 divided by 2, which equals 5 halves, which is 2 1/2. Okay. So the midpoint formula is simply adding your two x's, divided them by 2, adding your two y's, and dividing them by 2. Graphically, if you don't remember these, put yourself a triangle with points on it and think about how would I get, if I were to connect these and have the right triangle. I know the Pythagorean theorem. I know if I have to go in the middle, I am averaging. When we average numbers, we add them together and divide by 2, right? So if you score 10 points in one game and 20 points in another game and 30 points in another game, what is your average points per game? You would add it all together. Yeah. And then you would divide it by 3. Okay. See, we get the sports things, right? Okay, so circles.
We draw circles now on the class.
Any questions about circles? Distance formula, midpoint. Some of it's just practice. I want to be able to have time to do practice. Okay. Let's.
Last circles.
Does anyone have their book?
Yeah.
Mine goes right here.
Yes.
Box with a question.
Oh, yes,
Oh,
sir.
was that how you asked me to go to the bathroom?
Are these notes or worksheets?
These, the ones that I gave you out,
Yeah.
they are going to be your notes and your homework.
Okay.
The
okay.
circle, everything except the conics section.
Yeah, you won't have anything extra. Yeah, the conic sections is just the thingy.
Wait, it's just these?
Okay.
What, can you repeat that?
Hmm?
What'd you say? What was that?
The papers that I handed out will be part of your homework.
Part.
Wait.
More.
There's not much more. There's a project. Okay, so let's look at it.
That word makes it so much harder.
Okay, so let's look at number 4 on your circle.
Okay.
All right, where is the center?
-3, 1.
-3, 1. Excellent. What is the radius of your circle?
Wait, that's not a good number, right?
Well, you can tell me what
It's
it is.
like 2.5, right? 2.5 ish. Wait,
No, I not in a. Say it in
it's a square rooted. It's like 8 square rooted.
square root of 8.
Yeah.
So 2 square roots of 2. You can leave it as that.
Okay.
So if we know our center is at -3, 1, and my radius is 2 square roots of 2, give me a point on that line, on that circle. Any point.
I don't know what the 2 square root of 2 thing is.
That's the radius.
But like, how do you do that?
Do you just go 2 and then a square root of 2 more over?
Yeah, if we were going to write it in a point, so for example, -1 and then 1 plus 2 square roots of 2 is a point on that circle. Okay, I'm not talking about graphing it. If you were graphing it, okay, square root of 2 is a little over 1. Okay, so if you were graphing it here and we had -3, 1, my radius is, and you can use a calculator for this.
2 something.
So I gotta go this way.
2.35.
You just do. Did you do it on the square root of 8? 2.8.
Oh.
Ooh, you were off.
So
I
I'm
thought it was
almost
more than
3.
2.5.
1, 2, 3. I'm almost 3 there.
So it'd be negative.
Almost 3. Is that, so then you would just graph it like that.
Almost 3.
Okay? That make sense?
Is that what
That's number 4.
Oh, this is homework. We can just doing it.
Okay. Good, take notes if you want. Okay, number 5.
Oh,
Okay, so they tell you, or sorry, number 6. They say 5, 1 is on a circle centered at the point 1, 3. Okay, so we're going to take our initial equation. Which one is our center? For number 6? Which one is our center? They say 5, 1 is on a circle centered at the point 1, 3. So I know 1, 3, so I'm going to label it X and Y. This was something that I noticed got messed up on some homeworks and stuff. X is always first, Y is always second.
Oh, yeah.
Okay? So I'm going to do X minus 1, Y minus 3, and now I need to know my radius. They don't give me my radius. They give me 2 different points. So how do we find the radius? We're going to use the distance formula.
which one is this?
Number 6.
On the circle.
Number 6 on the circle. Handout. Okay. So 5, 1 is on a circle. We're on number 6 on the handout. Somewhere. It's on a circle centered at a point 1, 3. So I already know a significant portion of my equation because I've just plugged the center into the left side of my equation. Now I'm trying to find the radius over here. The radius is the distance between these 2 points. So we know from our Pythagorean theorem that our distance is the difference between our x's squared, the difference between our y's squared. Make sure you go in order. Whatever one you choose as the first one has to be the first one in both of them, okay? So if you start with 5 and then go across, so the 5 has to be first, and then the 1 has to be first, and the 1 and the 3, okay? So don't flip them. Okay? So now I have the square root of 4 squared and negative 2 squared. So I have 16 and 4, right? So I have the square root of 20. Now, because my radius, so I can either write square root of 20 squared. What would be easier to just write?
Wait, doesn't that just cancel it out?
So it's just 20.
20.
Oh my.
So the equation of a circle with a center at 1, 3 going through a point 5, 1 is x minus 1 squared plus y minus 3 squared equals 20. Right?
No, but 20 is not the radius. It's the number.
20 is not the radius. 20 is the radius squared. So the actual radius is square root of 20.
She tricked you.
Okay?
Which would be like
2 on the outside, 5 on the inside.
All right. Let's do number 8. Write the equation of a circle in standard form. So we have x squared, and I'm going to rearrange it so that all my x's are together, and all my y's are together, and then my number is on the other side. So do you see what I automatically did? X squared plus 4x, y squared minus 8y. I moved the 5 to the other side, so it went from negative 5 to positive 5. Get it? Get where we're at here?
Yes.
Okay, we're going to group and then do what?
Half square.
No, like, complete the square.
Complete the square. So what's next, Nathan? How do we complete the square?
Half square.
Half squared,
2, 4.
added on the both left and right. Okay,
4, 16.
16.
Oh my goodness.
Excellent. So now I have square root of the x, square root of the 4, use the middle sign. Square root of y, square root of 16, use the middle sign. Now I've got 9 plus 16. So now I have it in standard form. Can we graph this?
Yeah.
What's the center?
-2, +4.
-2, 4 is your center. What is your radius?
5.
Radius is 5. Okay. Plot this point, radius of 5, graph it around. Got it? Make sense? Okay. So, that's circles. Now, what happens when we change the curvature going around? We have an ellipse. Excellent. I'm going to do this because it's a constant.
You said it was 5?
It was 25,
No, but the radius.
so the radius is the square root of 25.
Yeah.
So it's not gonna fit. But
Yeah, it doesn't fit on that little graph. And you guys, I did post on their graph paper in a bunch of different, like that you can print off on our page, so do you want us to do that? Or I have a bunch here if you want to grab any. I printed it off for you guys to use, so feel free to grab
We
some.
still have some more from last.
We have some else about 16.
So, use that, okay. So, with an ellipse, ellipses are simply a squished circle. We're gonna have to move here. Okay. Whereas a circle has the same coefficient, ellipse is going to have a different coefficient. Alright? And that simply is telling us that the rate of change, that the rate of curvature changes as you go around it. Okay. A special thing about ellipses is that there's some different vocabulary that I want you guys to know. And it's not necessarily on here, so just write it as we go through. Okay? So ellipses have a center. They also have a foci. They have two different focuses, so it's called foci. Just like we talked about in a parabola, it has a focus, whereas the light bounces off of it. The way that we draw an ellipse, something that's special about it, is that if I had a piece of string and a pegboard, and we attached a piece of string to both foci, and we put a pencil in it, and we moved it, it would create an ellipse. That is how you form an ellipse. So the distance from any point on the ellipse to each foci will always be exactly the same. Right? So this is how we form. So if I had a string and I was moving this, what would happen over here? Now this distance is shorter, but this one is a lot longer. Right? So you're constantly going to be adjusting it, but you always have the same exact piece of string. So it's fun if you to do this with tacks at home and have a pencil. You can go around. You can make perfect ellipses. So that is how ellipses are formed. Okay. So ellipses, depending upon what direction they have, let's talk about this. They have a major axis and a minor axis. The major axis is the longest one. Okay? So in this case, your major axis is along the x-axis. Your minor axis is your shorter one, shorter distance across. Okay? So that means you have four vertices, okay? You have two vertices. So the ones that are going to be considered your major vertices will be the ones on your major axis. So if they say these are the vertices of an ellipse, it will always be along the major axis, okay? The ones along the minor axis are called your co-vertices, right? So this is one vertex, and this would be a vertex there. Right? Now, let's think about curvature. All right. So, if we were to look at this as two different parabolas, so we're looking up and down, and then left and right? This one is wide, right? This is a wide parabola. And this one is skinny, if we were looking that direction, right? So the coefficients of in our formula will determine what direction our ellipse goes. So let's walk through practically what that looks like before I tell you, just give you the answer. Okay. So if I have, so when we think of a parabola, the lower the number that we have, the wider it gets, right? Because we're getting closer to 0, right? The higher that the number we get, the skinnier it gets. Okay, so if we have, let's look at x squared plus 2y. In this case, we have a constant for a circle. Now, for an ellipse, we're going to have to change that because do we technically have a radius?
No.
No, we don't have a radius. So the problem becomes if we try to put a radius, it's not the same all the way around. So what we're going to do is we're going to divide. Remember our math rules? Divide by one side. We're going to get rid of that radius. And we're going to end up with the number 1. Okay? So on your formula, see it says we've got x minus h squared. We've got y minus k squared. We're looking at the horizontal ellipse. And we have it equal to 1. Okay? Now, on the bottom, they have an a squared and a b squared. Okay? So how do we end up with these numbers? Well, whatever we had the coefficient divided by the constant is going to give us a new number under there, okay? Same across. So just like with parabolas, when we have the higher and lower numbers, so whatever one is going to be your bigger number is the direction that your ellipse is going. Okay, so let's look at this one. If we have x squared plus 2y equals 1. Okay, our x is curving lower, right? So if I were looking at this as a parabola, my x is curving at a rate of 1, right? So I'm just going to put a standard, kind of a standard parabola in there, right? If I were to look at it where I'm looking at the y-axis, so we're going this direction, it's 2, so it's a skinnier. This side would need to be skinnier, right? So this would be a curvature of 2. This direction is a curvature of 1. Right? So this is why it ends up when our coefficients are different, we're going to have some different curvatures we're looking at for ellipses. Okay. So we went over major axis, minor axis. Okay. It is going to, we are going to maintain, so when you're looking at your equation at the top there, we maintain our h and k in our equation. If it doesn't have the h and k, that means it's stationed at the origin, right? Because the H and K simply tell us if it's moved around, right? So let's look at an example. Four x squared plus 9y squared equals 36. Okay. Going back to our questions, first off, how many squared terms do we have?
2.
Two. So it's got to be either a circle, an ellipse, or a hyperbola. Are our coefficients equal? No, so it cannot be a circle. Okay. So if it can't be a circle, the next problem is that we have a constant on our right side. We need to get rid of this constant. So we're going to divide everything by 36. So I'm going to have I'm going to change it where I have 1 on that side. Okay. Now I don't want to leave this as 4 over 36. I want to reduce it. Okay. They're being added together. I want you to see they're being added together because this is 2 an ellipse. No matter how you look at it, are 2 different parabolas that are being added together. Right? So that they're all consistent. Okay. Now we've written it as x squared over 9 plus y squared over 4 equals 1. These numbers at the bottom give us important information about our ellipse. They need to be written in squared terms, just like when we had our circle and we like to write it as a radius squared instead of just a number. So if I were going to rewrite 9 as a squared term, how would I rewrite it? What is 9?
Square root of 3.
3 squared. And 4 is
2 squared.
2 squared. All right? So now, if I know that my coefficients here affect the curvature, my x has a greater curvature, right? Or a bigger number, and than my y does. Right, so when we graph this on a graph, the number under the x tells you the points that you're going along the x. The number of the y tells you how many points you're going along the y. So let's look at this. Am I stationed at the origin or am I off of the origin? Is there anything added? Do I have an h and a k added?
No.
No. So we're going to start at the origin on it, just like with a circle. Okay. Now, this 3 under here is our A. What it tells me is the value that I'm going to move along the x-axis. So you need to make sure that your numbers line up with your variables that you're using. So along the x-axis, I'm going to move 3 points. 1, 2, 3. 1, 2, 3. Okay. Now, along my y-axis, I'm going to move 2 up and down. 1, 2. 1, 2. And then I would draw my ellipse. All right. Does that make sense? Okay. So the numbers underneath, the coefficients, tell us how we are moving along it. So let's think about it. As these numbers get closer and closer together to where they end up being the same, what shape do we get?
Circle.
A circle. That's why when the coefficients are the same, it's a circle. Okay? As these numbers get further and further apart, what happens to our ellipse?
Skinnier.
Yeah, it gets more and more squished. Okay? Our solar system happens to be an ellipse, and the sun is at the focus of our ellipse, of the orbit, which is interesting. So there's a real life practical application for that. Okay. So let's look at Let's work through another one. 25x squared plus 9y squared equals 225. So first off, we know that, what shape is this?
An eclipse.
An ellipse.
That's what I meant to say.
Okay, because we have two squared terms, but the coefficients are different. Okay, so I need to turn the right side into the number 1, first order of business. So when I divide, I end up with x squared over 9, y squared over 25. Okay? How far am I going to move along the x-axis?
3.
3. Because 9 is really 3 squared. 25 is 5 squared. So if I am graphing, I'm now moving 3 along the x-axis, but what am I moving along the y-axis?
5.
I'm moving 5. 1, 2, 3, 4, 5. So now I have an ellipse that is vertical. Okay? If the y is the bigger number, it goes up and down along the y-axis. It's vertical. Do we see that? When the x was the bigger number, we had this one. When the x is the bigger number, your ellipse lays, your major axis lies along the x. Okay? So whatever number is your biggest number, that is your major axis. Do you see that? Do you see why that's changing?
Yeah.
So let's work one. Yes.
Max has a question.
Why did you switch the 9 and 25?
I did 25 divided by 225, which is 9.
Oh.
And 9 divided by 225 is 25. These happen to use the,
I was so confused.
when they're multiplied together.
I was like, but x is...
Okay. Let's work one of these. And then I want to hit,
The lunch.
no, I want to hit hyperbolas. Okay. So, in this case, what I'm going to show you right here, we're going to keep all of these the same, dots the same. I'm going to show you how to turn this equation into a hyperbola.
Hyperbole.
A hyperbola is simply the exact same curvatures subtracted.
Oh.
Okay? If I took this equation and I put a minus sign in it, the way that I like to think about it is that, because with hyperbolas, it doesn't matter what comes first, whether it's x minus y or y minus x. When I am subtracting out the y-axis, I am removing the y, which means my graph will not include the y-axis. So my hyperbola will be left and right.
They're breaking up.
Okay? Breaking it up. If with a hyperbola, if I had these switched around where it was y squared, I'm going to do all of these, minus x squared, okay? I am subtracting out the x-axis, so while I use the same points, my hyperbola is now vertical. Okay? So if we use these, let's look at this equation, same equation. When we add them together, we got this really cool ellipse. Right? When we start subtracting, let's look at the first one. X squared minus 9, x squared over 9 minus y squared over 25. So our same thing, our a and our b are still the same. We're still dealing with 3 and 5. All right? Instead of drawing an ellipse in there, we are going to draw a square. we are going to connect these points with a square, okay? So now I have my square. When I add them together, my ellipse fits inside my square, right? There's a special name for the lines that go through each point in the center, each corner in the center here. These are called asymptotes. This is how you graph a hyperbola, okay? So, trying to show you how these are all connected. We have formed our square based upon how far we're moving on the x, how far we're moving on the y. So we formed our rectangle here, okay? Our ellipse, when they're added, fits inside of it. When we start subtracting them, we draw this cool X through the center and your points. Your vertices stay the same. So remember we had our vertices along our major axis for this one. Our major axis is on the Y, right? Because it's bigger on the Y in this case. So now, by x squared minus y squared, when I'm subtracting the y, I don't want to include y anywhere in it. So I need to look at my equation here. Here was one of my other vertices. And we're going to go along this line, and it goes up and it follows the asymptote. It gets closer and closer into it. So we would take the vertices from our ellipse, and this would be our hyperbola for this first one. Okay? Same numbers, same equation, same vertices. We're 3 along the x-axis, we're 5 along the y-axis. I do not want to have the y-axis as part of my equation, so I'm going to use my x vertices for my hyperbola. Okay? Now, if we switch this around and we make the y go first, y squared over 25 minus x squared over 9, okay? Same numbers, 3 along my x-axis, 5 along my y-axis, still using my vertices. I'm now having a vertical hyperbola. Because I do not want to include the x-axis. Okay? This is how they all work together. So same numbers for the equation, depending upon what's in front and what's subtracted and whether they're not added together. We can have 3 different graphs off of the same numbers. Do you see that?
Okay. I was gonna ask, does the 5 mean anything, but you said the vertical ellipse, if they switched, right?
So the 5 tells us so the 5 here, whenever it was the ellipse, it tells us the distance along your major axis. Okay. It also just gives us these here for a hyperbola. They give you your points so that you can draw your asymptotes.
Do you draw both of them?
Mm-hmm.
Your vertical
Well,
and
yeah.
your...
Yeah, it's always going to be an X, and then you just have to know, because when you have an X, I didn't do that right. When you have an X through a box, you now have options. You have this section here and here, or you have this section here and here that you could fill in.
So when they ask to graph, you graph the vertical and the horizontal one?
No, you would graph whatever one it's asking. There are 2 different ones, okay?
Okay.
Let's do one. We have a few minutes. Let's do
Number 3.
do number 3 on the ellipse, and then I'm gonna do another video. I'll do videos over each of these handouts. Okay?
Thank you.
Walking through some of those. So number 3, let's just walk through what it says. What is the center on number 3? We've got x minus 4 squared over 20, y plus 2 squared. So what is our center?
4 negative 2.
4 negative 2. Perfect. All right. What is our a? So I know if I'm kind of graphing this, I'm going to 4 negative 2. All right. How far am I moving along my, and that's not a great one because it's got a square root in it. Am I moving, let's make that 25.
Yes.
Go ahead and just change that to 25 on number 3. Change that number.
Which number? 20, the 20 or the 20?
Change the 20 to 25.
Make it easy.
Okay, so how far are we moving along the x-axis? 5. So you would go 5 to the left and 5 to the right,
And then 6. Oh wait.
okay? And then how far would you move up and down?
6.
6. So is this ellipse, is the major axis vertical or is it horizontal?
Horizontal.
Up and down.
Vertical.
Up and down.
Okay, 36 is bigger than 25, so
Vertical.
the y is going to be your bigger one. So your major axis on that one is going to be horizontal, okay? So to find your vertices, you would simply, so your vertices are going to be that y one, right? So your x is going to be the same. So for your vertices, automatically your x value stays the same. And then you would add 6 to your y and subtract 6 from your y, correct?
Yeah.
So we would have negative 2 plus 6, and we would have negative 2 minus 6.
Would those
So
be
we'd have 4, 4, and 4, negative 8. So both of those numbers are your vertices. Then for your co-vertices, so that's going to be the direction that's skinnier, which happens to be along your x-axis. For your co-vertices, your y stays the same. So you would automatically just write negative 2 in both of those, okay, because your y stays the same. And then we're going to add our 5 and subtract our 5. So we'd add 5 to our center and we'd get 9. We'd subtract 5 from our center and we'd get negative 1. Don't worry about filling in the foci, okay?
What was the center?
4 negative 2.
Center's 4, negative 2.
And the vertices was 4 negative 8.
One of the, yeah, so when you're dealing with an ellipse, you have 2. If it says vertices, you should have 2 coordinate points. Because you have your center and then you have a vertex on top or bottom, or you have vertex on left or right. You actually have 4. You have 2 vertices, which are on your major axis, and you have 2 co-vertices, which are along your minor axis.
Okay, so your 2 main ones are on the x-axis.
The 2 main ones are always on your major axis, depending upon what direction your graph is going.
Wait, but
Whatever the longer side
the
is.
36 is bigger.
Yes, 36 is bigger, so that one goes up and down.
That's the major.
So your major axis is along your y. So it is a vertical ellipse. Okay. Let's look at, got a few minutes, let's look at something on the hyperbola. Let's look at that number 1 on your hyperbola. Okay. 9x squared minus 16y squared equals 144. So number 1, we have 2 squared. They are subtracted. Since they are subtracted, it's a hyperbola. I'm just going to immediately rewrite it because I know that 9 times 16 is 144. So I'm swapping them. Okay. I'm going to rewrite 16 as 4 squared. Rewrite 9 as 3 squared. So I have rewritten that equation in my hyperbola form. So number 1 on the graph, because my y is subtracted, this hyperbola has to be a left and right. Right? Because I am not having y in my graph. The y-axis is not included in my graph. So it has to be a left and right.
The center is 0.
Or it's also called a horizontal, okay? Because I have nothing, no extra numbers with my x and my y,
It's 0, 0.
my center
It's the origin.
is at the origin, is at 0, 0.
Yes.
Okay? Which means that along the x-axis I'm going to go 4. So my vertices are what?
Negative 4, 0, and 4, 0.
Negative 4, 0, and 4, 0. Perfect. The y is 3. And it is simply so that I can draw my rectangle and put in my asymptotes. And then we graph that hyperbola along those asymptotes. Okay, so I was able to put my hyperbola on the graph before I even put in my asymptotes, correct? Because we already knew that it was a horizontal hyperbola. And don't worry about writing the equation for those asymptotes. Now, I'll go over that. Okay, so big picture, I know we covered a ton today. Big picture, do we see how all of these are really the same thing, just rearranged,
Yeah.
depending upon how we look at them?
Yeah.
Does that make sense? So we're basically dealing with the same equation of an x and possibly